Big data analytics. Big data analytics. When we say big data, it refers to not only the volume but also a few more attributes we are going to see. So, big data is the terminology that has come in to represent data. So, the whole of computer science and the information technology is all about data processing the data. Today we call it data science, but initially we called it as data processing. We called it electronic data processing, EDP. In every company, some 25-30 years ago, there were departments called electronic data processing department, EDP department. The EDP department will be the owner of the computers and the data processing operation. They will generate the reports, they will generate the required reports and so on. So, when we started as a data processing 25-30 years ago, the volume of the data was not so big. However, over a period of time, the data has grown in not only size but in variety, so that we call it big data. Big data. It can be compared to an elephant, a large volume of data. If you go to one particular area of the data, you cannot find out exactly the characteristics of the business. So that is why it can be compared to an elephant. At one point in time, if you look at it, will look only like a rope, because you are looking at the data in a particular region, whereas today it has become so big. So we have to look at the data science operation in totality. Only then we can come out with a proper result. So that is why big data analytics. So it's called big data. when we say the volume increases, it's important to look at the metrics used. What is the measurement? Normally we know that 1000 kilobytes, 1000 bytes form a kilobyte. 1 byte is a 8-bit data. 1 kilo KB means 1000, approximately 1000. It is actually 2 to the power of 10. Then the next one is into 2 to the power of 10. So that 2 power 10 into 2 power 10 is 2 power 20. So if there are 2 power 20 bytes, it's called megabytes. Similarly, 1024 megabytes form the gigabyte, GB. 1024 gigabytes form terabyte. 1024 terabytes form petabyte. The symbol is P. 1024 petabytes form exabytes. E is the symbol. 1024 exabytes form 1 zettabytes. 1024 zettabytes form 1 yottabytes, which is denoted by Y. So this is the table. This is a list of metrics we use. Now let us look at the volume growth. In 2018, there was a study made and they predicted that by 2015 there will be 175 zettabytes of data that will get generated. By and large, that prediction seems to be true. So 2 to the power of 10 is a kilobyte, 2 power 20 is a megabyte, 2 power 30 is gigabytes, 2 power 40 is a terabyte, 2 power 50 is a petabyte, 2 power 60 is exabyte, 2 power 70 is zettabyte, 2 power 80 is yottabyte. So that is how it is. Some people say 5I. Volume, variety and velocity we have studied, we have talked about. And also there are two more V parameters. One is the value, exact meaningful data. For example, in a bank, if the data says that a person's account balance is 1,000, it may mean $1,000. If it is 100,000, it is $100,000. So it's $100,000 money, the value. When somebody opens a social media and types some data, it may not have much value. So the value of the data changes from one type of data to another type of data. So the value is drastically different for various data. So the value component has to be considered. The fifth one is veracity. Veracity is about how much I can trust the data. So because of the open nature of the internet, we don't know how to trust the data that is published. So reliable, trusty data is another component. So this is how we define. So big data, we call it big data because the volume is high, variety is many, velocity is rapid speed at which data is being generated and it is streaming, and the value significantly differ from one application to another application. The veracity also is different. The trustworthiness, the trust is different for different sources of data. Now let us look at some statistics about big data. There are a lot of people today, for the past 10 years I am seeing enormous amount of discussions happening. So there are some 10 important facts I am going to produce here. One, global big data analytics market per annum, in every annual revenue is estimated to reach $68 billion by 2025. So there are estimates. So these are all estimates. People expect that the big data analytics market will be 68.09 billion annual revenue. Similarly, there were 79 zettabytes of data generated worldwide in 2021 alone. That is why the velocity of the data is also increasing. In 1 year, 79 zettabytes of data have been created. The fourth point is 90% of the data in the global data sphere is replicated data, enormous amount of replicated data. So it's a big challenge to see how we can take the unique data. If you take one particular person, his personal details data is replicated in 100 different places. If you have a bank account in 2 banks, then they are replicated in both the banks. Similarly, IoT is another important area. So in the technology, people have found out how we can use sensors which can be deployed at different places so that it is able to collect data automatically and send it. So in 2019 alone, 13.6 zettabytes of data have been generated by IoT connections. IoT, Internet of Things, sensors. So that is producing enormous volume of data. Point number 6, by 2025, more than 150 zettabytes of data will need analysis. We need analysis for not a small volume of data, 150 zettabytes of data. In 2021 alone, there was 24% of big data revenue in software. In the total software, 25% has been in the big data analytics. Big data analytics business was 24% of the total software. Similarly, the COVID-19 pandemic increased the rate of data that breaches by more than 400%. Enormous amount of data have come in due to the COVID. By 2027, the use of big data application, data solutions and analytics is predicted to grow $12 billion. In 2027 alone, the growth will be $12 billion. It will become $12 billion by 2027. Between 2021 and 2022, the worth of big data market is estimated to jump to 30 billion in value. So these are all some statistics which are produced by various people. We believe that these are reasonably reliable statistics. They are produced by various agencies, various market research units. So we need not go into the minute details of these things. But this will give you a big picture of what is it. Now, let us look at the important big data tools. In big data analytics, Hadoop is a very important tool. Hadoop has been a very popular tool. Actually, there is another tool by same Apache called Spark. On top of Hadoop, today Spark is giving beautiful results. Spark. In a similar manner, Tableau, Cassandra, MongoDB, Elasticsearch, RapidMiner, Qlik, Nine, Splunk and R are some of the popular big data tools. So when we say that variety is high, volume is high, velocity is high, because of these things, there are certain challenges for the software community, for the business community. Capturing the data itself is a huge challenge because of the variety, volume and velocity. Capturing the data capture, data storage, enormous volume of data, space is required to store the data. Similarly, data analysis is a big problem. Searching, sharing the data between parties, transferring the data from one place to another, data visualization becomes more and more complex. Querying becomes very complex because of the enormous amount of volume and the variety. Creating an appropriate query and getting the right data is a challenge. Updating the data updating the information. The most important thing is about the security, the privacy of the data. Data privacy is hit very much. Similarly, the data source is a challenge to understand, because of the internet, to understand exactly from where the data is coming. It is another big challenge. So we have studied about the challenges of big data. So in this particular lecture, we introduced the concept of big data. What are the three V's? 3V: velocity, variety, and the volume. And then two more V's were added. So that is how we look at the complex data system, big data system. We have seen some statistical statements, some 10 statistical statements to explain the size of big data, to explain the complexity of big data. We also listed what are the popular tools, big data tools today available in the market. And finally, we listed key challenges we must be careful in managing the big data. Thank you very much.